Hello my dear student, I welcome you all to the maths class. So in today's class we'll be starting exercise 3.1, question number 1. Question number 1 state that which of the following statement are true. So number part A state that if a number is divisible by 3, it must be divisible by 9. If a number is divisible by 3, right? If any number, say x is that number, is divisible by 3, it must be divisible by 9. So if it is divisible by 3, then it is also divisible by 9. So let's take an example. Say suppose this x is 3, okay, and this is divisible by 3. Yes, it is possible. But can this 3 divided by 9? Can this 9 divide 3? No, right? So this is the first condition in which we are getting no, the statement is false. Say we have another statement 6. Yes, 6 is divisible by 3. 3 to the 6. But can this 9 divide 6? Can this 9 divide 6? No, because 9 is a greater number and it cannot divide 6, greater number, smaller number. So if a number is divisible by 3, it is not compulsory that it is not divisible. It must be divisible by 9. So the statement here is false. Okay, I hope this is clear. I hope the example which I have given here is understandable to you all. So that's why the statement is false. Okay. Next, if a number is divisible by 9, if say again x is divisible by 9, it must be divisible by 3. It must be divisible by 3. Okay, yes, the statement is absolutely true, but I will show you the example also how. So any number which is divisible by 9, say 18. In the table of 9, if you go through all the table of 18, if you see 9 to the 18, 9 to the 27, 9 4 to 36, 9 5, all the numbers are divisible by 3. Yes, so you can try, you can have a look. Okay, so 9 2 is 18. So can this 18 be divided by 3? Yes, 3 6 18. Yes, this is possible. So this is the first example I'm giving to you. Next example, say 27 is divisible by 9. 9 3 is 27. Again, is this 27 divisible by 3? Yes, 3 9 is 27. So in both the case we saw, and you will see, taking many example, you can prove this statement that if a number is divisible by 9, it must be divisible by 3 also. Clear? Okay. Next, a number is divisible by 18 if it is divisible by both 3 and 6. The statement is absolutely false. Why? Because a number is divisible by 18. Say I'm taking 24 as an example. 24 can be divided by 3. 24 can be divided by 6. Can this 24 divide? Can this 24 be divided by 18? No. 18 2 is 36. 18 1 is 18. So in this case, 24 cannot be divided by 18. Right? Let's see 30. 30 can be divided by 3. 3 10 ja. 3 10 30. Right? And 30 can also be divided by 6. That is 6 5 ja. Sorry. 6 5 ja 30. But can this 30 divide? Can this 30 be divided by 18? No. How? How is that possible? It cannot divide. 30 cannot be divided by 18. 13 2 is again 36. Right? So hence this is proof that 18, it is not compulsory that number is divisible by 18 if it is divisible by both 3 and 6. So this statement is absolutely incorrect. So let's solve the next one. The next one we have here is if a number, okay, if a number is divisible by 9 and 10 both, if a number is divisible by both 9 and 10, then it is divisible by, it must be divisible by 90. So yes, as because 90 carries a factor of 9 and 10. Yes, 90 is a multiple of 9 into 10, so it has a factor of 9 as well as 10, so we can say that the statement is absolutely true. So let's see the example also. If a number is divisible by 9 and 10 both, say I'm taking an example. Say for example we have 180. Okay, so 180 is divisible by, 180 is divisible by 9, 9 20s are, yes, and 180 is also divisible by 10, 10 into 18. So in this case we can say that 90 carries a factor of 9 and 10. So if a number is divisible by 9 and 10 both, okay, then it must be divisible by 90 also. Okay, so in this case also, 180 is 180 is divisible by 90, 92 ja, yes, 2 ja will be the answer. Okay, so this way we will prove the statement. Okay, so now let's do the next one. The next one here we have is number E. If two numbers are co-primes, so you have understood in our last class we have done the concept of a co-prime in which the common factor is only 1. If two numbers are co-primes, at least one of them must be prime. So this statement is wrong, as because how? Because whenever we are comparing any number as a co-prime, the pair of a number should be there, right? So let's take 15 and 32. 15 and 32. So 15. So let's find out the factor of 15. 1, 3, 5. Yes, and then 15. Next we have 32. We 1 to 16 ja. Yes, 4 8 ja. 4 8 ja. Then comes a 6 to 16 ja, then 32. Right? So you can see this is only the one. This is only the co-prime number, as because the factor is only 1. As the factor is only 1, common factor is only 1, so hence 15 and 32 are co-prime number. But 15 and 32 both are composite number, right? So this statement is false. I hope you have understood this. So you can take the various example. Yesterday in our previous class we have done various sum in which the common factor was 1, but it was not compulsory that that at least one of them must be prime. It's not very compulsory. Okay, so this way we will solve it. This is the statement. Okay, so hence the statement is false. Proceeding to the next question, number F. The next question we have number F. All the numbers are divisible by 4 must also be divisible by 8. The statement here is false, as because let's take an example, 12. So let's take an example, 12. 12 is divisible by 4, right? 12 is divisible by 4. But can this 12 divided by 8? Can this 8 divide 12? No, not possible. Okay, let's take an example. Say for example we have 4. 4 can divide 4, which is 1. Can this 4 divided by 8? Not possible. It's in smaller number. So hence the statement is false. So let's write the statement is false here. Alright student, I hope you are understanding. I'm showing you the example as well. You can try with various example. Okay, so and you can prove this statement false. Next, number G. All numbers which are divisible by 8 must also be divisible by 4. Yes, this is the opposite statement and this is true. You can check it with the example. Your own example you can make it. So all numbers which are divisible by 8, okay, also divisible by 4. So you can take the table of 8, multiples of 8, 8 1 is 8, 8 2 is 16, 8 3 is 24, 4 8 is 32, 5 8 is 40, 8 6 is 48, 7 is 56, 64. So all these numbers are divisible by, not only divisible by 8, as of course this is divisible by 8 as because this is a multiple of 8, but can also be divided by 4. 4 2 is 8, 4 4 is 16, 4 3 is 24, 4 16 is 32, sorry, 4 8s are 32, 4 10s are 40, 4 12s are 48, 4 18s are 56, right? So 4 18s are 64. In this manner, we can check it out. The multiples of 8 is divisible by 4. All right. So likewise, number I and number H and I, sorry, number H and I want you all to do it yourself. Okay, with an example, you will show me how you are getting this. Okay, so I hope you are not having any problem till here. You have understood this. If you have any problem, feel free to share with me. Okay, so let's proceed now to the next question. Our next question is question number 2 from exercise 3.5. It states that here are two different factor trees for 60. So 60 here factor tree is made for you all. Factor tree is not nothing but just a tree of a factor, branches of a factor. So 6 into 10. 6 and 10 are the factor of a 60. Now to get 60, what we have to do? 2 into 3. So we have to fill in this blank. So this blank will be filled by 3. This blank will be filled by 3. Yes, because 2 3s is 6, isn't it? Right? Very easy one. 2 3s is 6. Now to get 10, what we have to do? 5 into 2 is 10, right? So here we can write 5 into 2 is 10. So these are all 2 3 5 2 are the factor of a 60, which we got using the factor tree. Okay, so now next we have to fill this blank circle here. So 60, it is divided by now 30. First number is 30, and by multiplying with which number you will get 60. So 30 into 2 is 60, right? So here it will be filled by 2. It will be filled by 2. Now next, 10, how many by multiplying with which number you will get 30? 10 3 is 30, right? And you can here easily see that you can get that 2 into 5. You cannot write 10 into 1, as because we have to break the number. Okay, we have to break the 10 into its 2 factor. So that's why it is written as 2 into 5. Right, students? So I hope you have understood this. So this is the factor tree for you all. So I want you all to do this yourself. So I'm making one extra factor tree for you all. So 40 I broken down as 2 into what will be here. Okay, and into what will be there. So this will be a homework. Okay, so try it yourself. Having any problem, you can share with me. Proceeding to the next question, question number 3, we have which factors are not included in the prime factorization of a composite number. So you all know that composite number has got more than uh, more than two factors, right? So what are the factors that are not included in prime factorization method? So when we are finding the factors of any number, we include all the numbers, right? Say for example 12. When till in our last class, what we have done, we have included all the factors starting from 1 1 2 6 3 4 6 and 12. We have included all the numbers whatever were there. But whenever we are doing the prime factorization concept, later on I'll do this. Okay, prime factorization method, whenever we are doing so I'll show you the prime factorization also. So let me show this also. Let me do the prime factorization method and find out the factors. 2 6 12, 2 3 6, 3 1 3. So we can write as a for whenever we are finding using the prime factorization technique, whenever we are writing the factors, it should be written only the numbers whatever we got. That is 12 factors will be 2 into 2 into 2 into 3. Okay, 2 into 2 into 3. So what is missing here? What you can see what is missing here. So 3 is there. Okay, 3 is there. 2 to the 4 is there. Yes, 4 is there. 2 is there. 2 is there. Okay, and 2 3 is 6 is also there. 6 is also there. But what is missing here? The thing missing is 1 and the number itself, right? 1 and the number itself is missing. So whenever we are finding the prime factorization method of any composite number, 1, okay, that is number 1 whenever we are writing any factors till now, what we did, we wrote 1 as well as the number itself. So 1 and number itself, of which composite number we are writing. Yes, 1 and the number itself are not included. Not included in the So you all know, I guess, what is the greatest prime number? The greatest, sorry, not prime number, greatest 4-digit number, right? So greatest 4-digit number is 9999. Greatest 3-digit 999. Greatest 5-digit 9999959, right? So we have to find the factors. We have to express this 4-digit number, greatest 4-digit number, in its prime factors. So in what manner I have done that, you can use, or you can make the factor tree also. You can make the factor tree also. So 9999, we have to make the, I'll be using the factor tree. You people will like this. Okay, so prime factor means you will use the smallest prime number and try to divide this. Do you think 9999 is divided by 2? No, as because the end of the digit or the unit position is odd number, so it is not divisible by 2. So the another factor or the another prime number will be 3. So 3 will be dividing. So I have told you, whenever you are doing so, you have to use the smallest prime number, that is 3, as because they have said us to find the prime factors. So 3 into 3, 3, 3, 3, right? Next, what we can do, again, this cannot be divided by 2, as because the 3 here is odd number in the unit position, so it will be again divided by 3 only. 3 into 1, 1, 1, 1, right? Now one more thing we can do, we can break this 1, 1, 1, 1 into as 11, sorry, 11 into 101. So this, both are the prime numbers, so all the composite numbers now, that is 999, whatever was there, is now converted into the prime factors. So what are the factors of 999 now? So you can see in question number 3, what was the question? Which factors are not included? 1 and the number itself. So do you see 1 here? Do you see 999 here? So the prime factors of 999 are 3. Okay, only we will write this number. Only we will write this number. So this and this. Okay, so 3 into 3 into 11 into 101 are the prime factors, right? Are the prime factors of greatest 4-digit number, right? So this is the way of doing, and here no 1 and not 1 as well as the number, that is 999, are represented. Okay, so this is the basic idea. I hope you people have understood this. Very easy one. So in our next class we will proceed with the next question then. Okay, till then, stay safe and healthy. Thank you everyone.